If you think about it, the only real integration technique we've ever learned is U substitution. It helped us on a lot of stuff that didn't fit the basic power rule. There's a lot more functions out there that U substitution is not going to work for, and you're looking at one right now, X sine of X. It's a product. There is no product rule. But we're going to learn today the closest thing we have to a quote unquote product rule, or sometimes you can think of it as a quote. It's called integration by parts. It's a really, really, really useful way to integrate many functions. You can see below it's based off the product rule of differentiation. We're not going to go over that. It's pretty interesting. So if you want to look at that, Google it or something. But it comes down to this. The integral of a product, well, you can think of it as a product, integral of u times dv is uv minus the integral of v du. This is integration by parts. This is the, I guess we'll call it the formula you're going to use. Notice we have a u and a v. So we're going to have two variables coming into play here. This doesn't always work. You can see that as part of the formula, you get an integral itself. So for this to work, this integral will have to be integrable. You'll see. So guidelines. You can read these guidelines. They're not, I don't think they're going to be that clear unless you actually see these and do them. But we're going to pick a u, like we always do, but we're also going to pick a dv. So notice the integral is not u du, it's u dv. So guidelines are try letting dv be the most complicated because we're going to have to integrate that. So it's going to be the most complicated part that we can actually integrate. And then u would be everything else. Because u we're going to have to differentiate. We can differentiate anything. The other guideline is you can let u be a portion of the integrand whose derivative becomes a simpler function. Say x cubed, its derivative is 3x squared. That's simpler. And then dv would be the remaining. Those are good guidelines to follow. They are guidelines. They don't solve all your problems. Integration by parts doesn't solve all your problems, but it solves a lot of them. So we're going to go back to this integral x sine of x dx. Notice that it is a product. So we're going to change this into the integral of u dv, which means, and we know that's u v minus the integral of v du. Notice we need to make it exactly this. So first I'm going to pick my dv because that's going to be the most complicated part that we can integrate. We know the integral of sine x, so let's call dv sine x. But not only sine x dx. You have to take everything into account. That means u is going to be x. Now, if you think of the guidelines, it's good to make u something whose derivative is simpler. The derivative of x is 1, that's simpler. If we chose it to be sine, the derivative of sine is cosine, which is not simpler. So this is a good start. Let's see if it works. So we're going to substitute. X is u, and sine x dx is dv. So we have it in this form. The result is u times v minus the integral of v du. Notice we don't even have a v here, so we're going to have to figure out what V is, and we're going to have to figure out what du is. So normally you would do this right away. I'm going to go over to the right first, the u equals x, because this is something we've been doing with regular u substitution. Whenever you pick a u, determine what du is, and in this case it's 1 dx. Now this part over here is new. We have dv, so to figure out what v is, you're going to have to integrate. The integral of v, dv is v, and the integral of sine is negative cosine. I heard you, you said you thought it was positive cosine, but remember your rule. We're integrating. So now all we do is substitute. So u is x, dv, u is x, v is negative cosine of x, minus the integral of v, which is negative cosine, so I'm going to write positive cosine, change this to positive, times du, which is dx. So this only works if that integral we're left with is integrable, which it is, because we know what the integral of cosine is. So we have negative x, cosine x, the integral of cosine to sine, add my plus c, and there you go. That's the integral of x sine of x. You can check that by taking the derivative, which I think we're going to do. This problem we'll save for the next video. It's getting long, but I think the check is important. So if you differentiate this, first one's a product. First times the derivative of the second plus the second times the derivative of the first. So it's negative cosine of x. The derivative of sine is cosine. Derivative of c is 0. Negative cosine plus cosine is 0. Negative times a negative is positive. There's your check. That's what our integral was. There you go. You can also check it with the calculator. You know how to do that. We'll see you shortly to figure out how you do this one.